are we at?
The machine shop.
What are we doing at the machine shop today?
We're gonna pick up our motor.
Yeah, we're gonna pick up our motor. Well, the motor's back from the machine shop. You can see the cross hatching on it where they've line honed everything. They went 30 over on the bore for each one of the cylinders, and they decked it for me as well. Well, this is going to be an exciting video. This is the first time for me putting together a motor with all new parts. In the past, I've built some motors, and usually there's a crankshaft that I'm reusing that I've gotten returned, or I've got components that I'm rebuilding. But aside from the block, this is going to be a video with all new internals. So as we talked about before, what I'm starting out here with, this is a 351 Windsor that came out of a 94 or 95 truck. The very first video in this series, I tore this down. I got it back from the machine shop. What he did was he took it 30 over on each one of the cylinders. He cleaned it, magnafluxed it, made sure there was no cracks. He also decked the block for me. You can see here, and he even stamped it at 8 thousandths. I was kind of hoping for 20 thousandths, but with my combo, that'll work out well. It'll give me a little buffer on my compression ratio. And he just line honed everything and really cleaned everything up. The first day I painted this, when it came back, I haven't done anything with oiling it because I'm gonna have to clearance it, which you're gonna see here in a second. But I wanted the outside to go ahead and get paint while it was fresh, and then it's been in an air-conditioned room with a cover over it. The paint for it that I used is just a Rust-Oleum product on both. I've got the primer. The day I did it, I couldn't find any of the engine paint that I have that I usually use, so I tried some caliper paint. We'll see how it holds up. I think it'll be fine. 900 degrees should hold up. I'll walk you through some of the components I've got here. So for the crankshaft, I went with an Eagle. I wanted a forged rotating assembly so that hopefully this one will last me for years. If I want to go a different direction, it's forged. I can push it a little farther. When you get these forged, they come neutral balance. This was new for me, so I carried it to a place in Jacksonville. There was a machine shop precision crankshaft. They drilled it and balanced it. They turned everything for me so that everything was zero balance, and that's going to play in later when we put the flywheel and the balancer on it. Attached to it, for the 408 cubic inches, I ended up going with a 4-inch stroke, and I've got Eagle rods. Now these are forged rods. These are really nice pieces, and again, they went through and they balanced all of them. You can see where they took weight off the small end, and some of them, the pads got ground a little bit on the big end. These are they're actually 6.2-inch rods. It's a Chevy type rod. That's what you need to get the right throw and the right deck clearance for all of the rotating assembly. And for the pistons, I went with the Summit brand pistons. Now these are a forged piston. I went with one that had a little more meat on the top, that were forged, that if I want to go nitrous, I have the option. The crank will certainly hold it, the rods will certainly hold it. The weak point in this combo would be the pistons, and they say on there that as long as you don't get wild with the nitrous, I think this will take 150 shot all day. To seal these up, I went with the Summit brand gas ported rings. Now when we're talking about this, you've probably seen in the past, they have gas ported pistons, which are great for race, but on a street application or over a longer period of time, I've seen a lot of videos where they gum up, and then once they're clogged, it's no different than a regular piston. So this is something new they're running. They're 1.5 and 3 millimeter, the smaller ring package, and they've actually got the grooves cut into the rings, and that helps with sealing. As the combustion chamber pushes gas through, it pushes everything out, and it just helps with a better seal. Working over to the heads, you probably have seen these heads over here. These are the Trick Flow Twisted Wedge, the 11R. These things are beautiful. They machine them with a real nice finish. They're actually ported from the factory when they send them out on these. There's a 227 they just came out with, I believe. There's a newer model that's a little bigger, and you can actually buy a port matched intake that goes with it. But for this application, the 205s were right where I wanted to be. That was perfect for the flow. There's some other videos out there of guys that are pushing over 700 horsepower through these 205s. So on top of the heads, I'm going to run Trick Flow. Most of the components are Trick Flow, just because it's all going to play well together. You can really run any of them, but I wanted a name brand, something that I hope will hold up. I went with the 1.6 rockers. Comp cams timing set. To drive this, I've got the cam card here. The camshaft I went with is a Trick Flow as well. And a lot of people, when you're building a fresh motor like this, will get a custom grind. But this combination I found with the stroke and the cam lift and the heads and everything, the fellow was running a Trick Flow Stage 3 cam, which is essentially what this is. It's designed for the 1.6 rockers. It's got a pretty decent lift, and the duration and separation is fair for the streets. So this will make power over 3,000 RPM. To really get the most out of it, I'm going to put a single plane intake on it, which I don't have yet, but that's going to be on back order right now. The oil pan. This is a truck oil pan. So for the Mustang, to clear this Mustang 2 type cross member, I have to run that truck pan, and there's a pickup that goes with it. Bearings. Truth be told, for the main bearings, I've run the Clevites in the past. I've had some issues with some of the finishes that come from the factory. I wanted to run the Kings, but I can't find them anywhere. Nobody had them. Everybody's on back order for the main bearings. So I went with the King Racing bearings for the rod bearings, and they're absolutely beautiful. The packaging's great, solid, everything's spaced, they're not beat up. This is their XP series that I went with for the rods, and then on the Molly main bearings I went with the P series. Cam bearings are cam bearings. I went with the Durabond. And for the oil pump on this might bite me. I may end up switching this back out. This is a high volume oil pump, and if you've built Windsor motors before, you know that the distributor gears have issues from time to time. Some people run brass. Some people do modifications to try to get better oiling by drilling a plug. Most of the time it's because of the extra demand of this oil pump. The ones I've seen online, the people who have issues, it's because they're running the high volume oil pump. I know a lot of people that have pretty high horsepower motors that run standard oil pumps. I may end up switching that out. Initially when I got it, I wasn't thinking, but we'll see once we get there. One of the good benefits, or the best parts of this block being a newer block, is the one-piece rear main seal. My last motor I put together, as soon as I finished it, that thing started to have a drip. I've tried RTV, no RTV. This is going to eliminate that issue. The one piece is going to be a nice feature. We won't have to worry about putting a two-piece together in it. And the last thing before I get into working on the block, I found this Total Seal piston ring assembly lube. Now, I usually just use the Permatex standard assembly lube, but this is designed for the cylinder walls. And what they say is you can put this in the cylinder walls. It helps the pistons actually seat, and once you put the motor together, it's nice and sticky. It's a thick fluid that will coat the walls and stop any kind of rust or moisture from getting in there and causing oxidation. Alright, so just like the other video, I'll jump into a time lapse and you can watch me put this together. So what I'm doing here is I'm checking to make sure that I've got clearance as this rotating assembly comes around. And I've got one spot here where I don't quite have 50 thousandths, and I've marked it. And every spot I mark I'm going to number, and I'll just put a little cheat up here so I don't miss any of them. I think most of these are going to have issues with the bolts. That's probably what's going to touch. As I spin this around, and I'll see if I can do it on the camera here. Might be tricky, but as I spin it around, I'm just making sure that I have the clearance that I need. So if we watch over here, you can see that that barely clears. And with the feeler gauge, I've only got about 30 thousandths clearance. Now that's the wheel channel right there, so I've got to be careful just to take what I need, but I'll go ahead and take a little bit of material off of that just to give me some more space. Alright, so I've got all my spots marked on here. Anywhere that you see blue are interference issues. I've got a couple here on the insides. Now, this thing had clearance all the way around, but it's only about 30 thousandths, and that might be alright, but I'd rather err on the side of caution. I'm going to go ahead and clearance this a little more in those spots, just to give me peace of mind if for some reason there's any flex or distortion. I'm going to shoot for the 60 thousandths, 50 to 60 thousandths mark. And the way I'm going to do that is I'm going to go ahead and deburr it with a burring tool. To do that though, with a carbide, I'm going to get away from the engine parts, and I'll probably do it right over here out of the way. First I've got to get this crank out of the way, and then once that's done I'll be able to clean everything up. Alright, so I'm clearanced here. You can kind of see it. All my blue is gone. I went a little extra on it, but I've still got enough material to get a seal here. I also hit the edges of the cylinder. I don't know if the camera will show it well. I'll spin around here. But I've got notches where those rod bolts are going to go, and I feel real good about it. I'm not going to reassemble because I left myself a good bit of extra with the blue, and I went past the blue. Lots of meat on the bottom here. I created a lot of burr dust, or a lot of grinding dust here, and you can see it in the cylinders. I've blown as much as I can out, but I need to get all this clean before I do the assembly. So I'm at the point now I can go ahead and soap water and scrub this thing top to bottom and make sure I get every bit of that out. the engine's all cleaned up. I came back through and towed off some of the excess WD-40, and then I went through and blew out all of the holes. That way I know all of my passages are clean. The next up is going to be installing all of the plugs. So I've got the freeze plugs that need to go in, I've got the cam plug, and then all of the galley plugs. I am going to mod one of the plugs, which I'll show you here in a second, that will let the oiling for the distributor gear be more effective. It'll basically be a hole just so that gear doesn't get wasted when I run that high flow oil pump. And I'm also going to install the cam bearings here. So with cam bearings, these things are stepped. They go in order, there's a number on them. And you'll start with the back one and work your way through. This is the one for here, and you'll see that it's a perfect fit. And the back one, and they all have a number on it, will be loose in this front one because it needs to go through each until it gets to the back. These are pretty straightforward. There's a driver tool that I use for them. I wanted to wait to install these until the block was clean, that way there's no chance of junk and gunk getting in them. The only thing to remember on these is there's a channel here. This is the oil opening, and you have to make sure that they're in line with each of the oiling slots. If you don't, your cam won't get any oil, and it's bad news. So back to the time lapse. I'll drive these in and I'll start putting plugs in. Well, my GoPro died on me, but I'll walk you through the process of what I did to put the freeze plugs in. So on the lathe, I just turned a little piece. This is a really hard, I think they call it acetal, but it's a hard plastic. And I turned it down to the perfect diameter so it fits right into a freeze plug. And then I've got a lip here, so once I get to the chamfer, it stops. I'll put a little bit of RTV sealant on it and just drove each one of the freeze plugs in. And I did the same thing on the other side here. Now I'm working on the oil galleys. I had to blow out a little bit more on these. I ran a flashlight through it to make sure they were clean. I've got one in. I'm going to put the other plug in here. I'm just using an aluminum rod for that. And then I can go ahead and put in some of the threaded plugs. Now, something worth noting when you're installing bearings, whether it's crank, main bearings, or rod bearings, You only want the lube on the side where the rotating part's going to be. So the back side of these bearings, I want them to be nice and dry, because any liquid that you put there is going to take up space and it's going to mess with your measurements. You don't want anything on that back side that's going to take up any space. Well, after measuring the bearings, the Clevites are running a little bit tighter than what I want. I'm between 2 thousandths to 2.5 thousandths clearance. I went ahead and pulled out a couple of them and started installing the sealed power, the Mach up bearings that I've got on hand. They're a tri-metal bearing, and they're showing to be bigger. I've got 2.5 to 3.5 thousandths on the first two. Now I'm going to continue to check these, but I think the reason for this is the H series Clevite bearings actually have a coating on them. Can you see it? Where the sealed power tri-metals, they don't. They're just a standard bearing, no protective coating. Now looking at the paperwork, as far as what's acceptable, I'm within the range. So let me jump over here and I'll show you. From the factory says that the clearance has a little bit of wiggle room. I don't know if you can see it here, but the factory clearance for the crankshaft bearings is anywhere from 1.5 thousandths to just over 2.5 thousandths. But being a performance motor, it's typically 1 thousandths per inch, and this is a 3-inch main, so 3 thousandths is really my target. And looking at these numbers, I'm a bit all over the place, so I'll have to come up with a plan of which bearings I'm going to use, but I'll make that decision after I put the rest of the bearings in and get all of my measurements. Well, I got all of my measurements, and what I found was the sealed power had the right gap that I needed. So those are the bearings that I'm going to run. I did have a little discrepancy between cap number 1 and 2. I was a little under and a little over, and as you can imagine, what I did was I simply switched the bearings between the two, and where that landed me was perfect. 3 thousandths on all of them, not even 1/2 thousandths off. So I'm really excited about that. I do still need to check my end play once the crank's in, but this allows me to now drop the crankshaft in, and I can mount that crank tonight. While it's out though, before I oil it, I need to do the same thing for the rod bearings. So what I'm gonna do is I'm gonna pull a measurement with my other micrometer. I'll figure out what the journal is here, and then I'm gonna follow the same steps as I go through my rod bearings and make sure as I mic it, everything's just right. I spent a lot of time debating whether I was going to use studs and a girdle on this motor, but after some research, there's some great information online of plenty of people running the factory bolts without any issues. It's not really a weak spot on these Windsors, but something I always do is I use the ARP fastener grease just to make sure that the torque specs are correct and what I'm putting into that torque wrench is actually translating through to the bolts and there's no binding. Skylar, what is this round thing that I'm rotating?
Piston.
It's not a piston. What is it? What is that part right here, Maddie?
Crankshaft.
It's a crankshaft. Careful, it's sharp. All right, let's try some other parts. You should know what this one is.
Piston.
Yeah, you know what that part is. What's on the bottom of the piston?
A connecting rod.
Yeah, you girls are smart. Where'd you learn all this?
They're building the engine.
Ah. And then this little piece in here, that's a tough one. What's this little piece called?
Ring.
Looks like a ring. These are rings on the outside. It's a wrist pin because it looks like a wrist.
Wrist pin.
Wrist pin, yeah. What do you think, Natalie? Yeah. Now that everything's measured and I know that everything's in spec, I went ahead and tore down the rods again. Everything got cleaned, blown out, all of the holes. Got the air blower just to make sure there's no residual left in them. And we're on to the pistons and piston rings. With pistons, there's always some math. These need to be file fit to make it work. I have all of the paperwork here from Total Seal, and what I've come out to is for naturally aspirated, they recommend 18 thousandths. For nitrous, 150 shot, which I may or may not run, 22 thousandths. So I'm gonna go ahead and run the bigger gap just in case. And conventional wisdom on piston rings, you typically run the second ring a little bigger than the top ring. You never want a condition where gas gets past the first compression ring and then can't get past the second. It causes some chatter. Total Seal says you can do it either way. Their videos online show gapping the second a little bigger. Their paperwork says to run it the same. I think I'm gonna shoot for the same, but there's always some risk of error. The ring placement. So there's a little chart that comes with it. What I like to do is on my little note board here, I just orient it to my motor. So top ring, second ring, my oil, and then the scrapers. I've started doing this already for filing them. I 3D printed a small little tool here, and what this does is it allows me to put the ring inside of the cylinder, and then I can press it in, and it just drops me to the height that I need to make sure everything's square. And I have a little ring filer here that I have a impact that I can hog it down to a close, and then a handle that goes onto it so I can really fine tune it. That takes more material than I expected, and the first one I did, I actually had a little bit of an error. So I'm shooting for 22 thousandths. My very first one, I hit 25 thousandths on that top ring, so it forced me to open up the second ring a little bit to match it. That way I don't get that chatter. But I've got 1, 2, 3, 4, 5 sets done so far. I've still got a few more. And then I can assemble these pistons and get them on the rods and get them in the motor. So with all the rings gapped, and I've got all my measurements that I'll transfer over, I can go ahead and start assembling the pistons to the rods. Just some things to keep in mind. These rods do have a chamfer, so this always goes in the block on the side towards the edge of the crank. And you can see the chamfer on the side of the crank. So I'll make sure I have orientation correct. I have all of my pistons and rods numbered and an arrow to show which way the front of the motor is. That way I don't mix any of this up.
Now to make room for the oil pump, I don't want to take it all out of the pan, so what I'm going to do is use the grinder to soften this edge right here and remove some material from this cap. I don't want to risk any contaminants in the motor after all the cleaning we've done, so I've made a little slot in a bag and I hit it with the grinder and tried to send everything I could away from it. Now I did this in steps and it took a total of 3 rounds.
Well, I had to take a lot more material than I was hoping. I rounded out the cap on this, but I got into the housing a little bit as well because I was having some interference issues. I finally got it where I want it though. I did have to massage the pan a bit too. I don't know if you can see it here, but I hit it with a hammer, which just gave me the little bit I needed to get the real nice clearance. I've been very careful to make sure this was bagged each time and taped around just to make sure no contaminants could get into the motor. That was a big concern of mine. I just got to be careful tonight with the bugs, trying to keep the bugs out of it like you saw there. Last thing I need to do is to trim this plug down. So the plug is just a little bit too deep into the pan, and that's my last bit of interference here. As you can see on this one, it sticks up. I'm gonna shave this down so it's pretty much flush with there and I can seal it up. Now when it comes to degreeing cams, there's a number of different ways to do this. Everyone agrees on how to find dead top center, right? 50 thousandths before dead top center, 50 thousandths after. You split the difference and that puts you right where you need to be. And I've got this wheel set right at 0 degrees for top dead center for the #1 piston. Now when it comes to setting the cam, you've got to go off of the cam card. And I like to start by finding the lobe center line. And once I have, I proof it by checking the intake and the exhaust at 2 different lifts. By doing this, I found that I was off on my marks the first time. My numbers didn't make any sense. I went back, checked the marks, and sure enough, I was a tooth off. So I'm glad I did this. When I do this now, we can look at 6 thousandths and 50 thousandths lift, right? So the intake at 39 degrees, so if I mark this back to 39 degrees before top dead center, I've put a little mark here. When I check this, I should be at 6 thousandths lift on my chart, on my dial indicator here. And then as I turn it over to 13 degrees before top dead center, so I've got it again marked at 13 degrees before top dead center, my indicator should read 50. Let's go ahead and test this out. So I'm just going to spin this until I land right at that first measurement of 39. There it is. And I should be at 6 thousandths. And when I check, I'm 1 thousandths off. So if I adjust this a 1/2 degree and we go in the same direction, it puts me right at 6 thousandths. And I've done this once before I filmed it, so I kind of knew what I was getting into here. And then the same thing on this other mark. If I spin this around to the other mark, right there, I should be at 50 thousandths. Again, I'm at 51 thousandths. If I adjust this back, and if you always go the same direction, so if you need to go back, you gotta go back a ways and then come forward. As I run this forward, if I can get this right to 50 thousandths, as you see here, you'll find that I'm a half a degree off of my mark. So I've got a couple of different options. It could be just in this wheel and this piece of weld wire that I've got, but I'm fairly confident in this setup. I'm a half a degree off on this cam. I can either run it, or I can go ahead and get a different timing set that is adjustable to make up for that half a degree. Tell me in the comments what you think you would do. Alright, so because I had that half degree discrepancy, and just to be thorough, I went ahead and borrowed a little bit of Play-Doh from my kids. And what I'm going to do is I'm going to clay these pistons. I'm going to put the head on without a head gasket and run through the cycle with a couple of push rods. Our Play-Doh, thanks for the Play-Doh, Natalie. Looking back at our Play-Doh, I didn't even touch it with the valve, so I've got plenty of piston to valve clearance on this setup. I thought for sure that would be a lot tighter, but I mean, you can see the thickness of this, and it never even got close to it. Installing the timing cover, I bought this ARP kit and I saw the reviews online. This is the 154-1503. A lot of people said the bolts don't fit their timing cover set, and they were absolutely right. What I ran into is only maybe 5 bolts fit, and the rest of these, I don't know what they're for, but they're certainly not for this water pump or this timing cover. Not a big deal. I've got some grade 8 bolts here that I've painted to kind of blend in. I hate that this is like this, but it's just that way sometimes. I've got 2 different sizes. I've got the 3/8 head and the 1/2 inch head, but if that's what you got to make it work, that's what you got. This is a little trick that I've learned in the past from working on these motors. You really need to install the harmonic balancer before you snug down your timing cover. If you don't, you may get a little off on the seal. So you saw me press the seal in, and you can kind of see it here. There's a certain degree of play in this cover when you're mounting it, where it'll move side to side for the radius of the opening of those bolts. So all I'm going to do is not final mount it, but I'm just going to slide this in carefully, make sure it doesn't pinch. And then what I'll do is I'll use the harmonic balancer to square up the timing cover where it should be, and then I can snug down the bolts and then pull that balancer back off. I almost messed up here. I don't know if you can see, but where the timing cover gasket is, where it comes to this bottom, there's always a little bit of overlap. And what I like to do there is trim it, like you can see on this side with the razor blade. I started to put the pan on it, and when I got the bolts in, I realized I had not trimmed it. So what I do is I'll come back with a little razor blade and trim that flush. And then I'll put a little bit of RTV right there at that mating surface also, just to make sure and ensure that there's no leak between the timing cover and the block.
Well, this is probably a good place to end this video. I've got the crankshaft, rods, pistons in, so the short block is assembled. Timing cover, oil pan. The next video, I'll go ahead and mount the heads on it, and I'll show you my process for setting push rod length and putting the top end together. Thanks for watching if you've stuck around this long, and I'll see you on the next video.